Okay. So hello everybody and welcome to the Reuse Company webinars. I'm sorry for these technical issues. You will be muted during your webinar, but if you have any questions, you can use the questions section. And in a few days, we will send you a link to the recording of the webinar. The topic for today is requirements management, managing data over entire life cycles. My name is Cecilia Karlsson, and I will be hosting today's webinar. With me, I have Lars Anderberg, application consultant at the Reuse Company, and he is today's presenter. This is the agenda for the webinar. First, we will have a short presentation of the company and the presenter. Then Lars will talk about what requirements management is. Next, we'll see the life cycle. After that, we will talk about the structure, traceability, and attributes. Then we will learn how to draw the map, and finally we will see a demonstration, and we will also have some time for questions. So first a few words about us. The Reuse Company is a tool vendor specialized in the application of reuse methods, semantic technologies, and artificial intelligence to improve the digitalization of the systems engineering life cycle. We promote lifecycle management methodologies guided by reuse, based on knowledge-centric approach, supporting the notion of authoritative source of truth, offering connectivity to everything, unlimited interoperability, and providing full support to technical management as in ISO 15288. We are usually known in the market for our software tools RQA Quality Studio, RAT Authoring Tool, Traceability Studio, VNV Studio, and KM Knowledge Manager. And now we are also launching our newest product, SES Engineering Studio. Let me introduce you to the presenter. Lars is an application consultant at the Reuse Company, and he has been working with requirements engineering and acquisition support for more than 20 years. Lars also has the INCOSE ESEP certification. So let's start then with today's topic. Hello, Lars.
Good morning, Cecilia, and good morning, everybody else, or perhaps good afternoon. Okay, I will be sharing some thoughts about requirements management with you, and to do that, we may need to start to define what is requirements management and when and where does it happen. And for that reason, I will show this V model picture from 15288. It may or may not be familiar to you, but there are a number of process steps in there where you obviously deal with and even mention requirements. We have, for example, these ones where we define business or missions and analysis, stakeholder needs requirement definition, and system requirements definition. The requirements are even mentioned in the name of these two. Further along down, we define architecture and design and making some implementation. And up on the other end, of course, requirements are still active all the way down here, of course. We integrate, we verify, and we validate, and in verification, we will make sure that the produced system or product satisfies the requirements, and validation should make sure that we satisfy the needs. So there are a number of areas where requirements really are essential. We could also mention that this model is iterative. It's definitely not so that you do one thing and finish off with that before continuing on, because we're iterating constantly throughout the whole model. So we're going back and forth and up and down in these different processes. And not only iterative, it's also recursive, because for example, if you would implement or integrate a component, this component may be the system for somebody else. So depending on who you are, whose view you're taking, there's not one single view saying that this is the V model, the universal V model, because it's all recursive. So things may repeat as subsystems or components add on. Okay, so where does requirement management happen then? Well, it's actually not in any of these. It's basically in all of them. is a supporting activity ongoing throughout the entire life cycle. And the task is to manage all data being produced throughout this life cycle to make sure it's consistent and so on. There are a number of terms here. We talk sometimes about requirement engineering, sometimes about requirements development, sometimes about requirements management. And development is perhaps the most obvious one that says that this is where you actually develop requirements. This is where you decide what the requirement statement should be and so on and so forth. There are some very powerful tools that will support you with this. In our tool suite, we have based on the ontologies and the knowledge manager, we have tools such as quality analyzer and things like that, which are very powerful tools to help you develop requirements with good quality. But if you need to manage it over time, well, you would have good support with the CS Engineering Studio, combining all existing tools and also connectors to all sorts of repositories where data may actually reside. If I would open up this box a little bit and say where does requirement development start and where does requirement management take over? As this picture indicates, there is no strict border in here, sort of soft transition in here. However, you could say that on the development end, you're more towards the defining and deciding and specifying requirements. And on the management point of view, you're more towards providing structure and establishing and enabling traceability and reviews and all sorts of things here. So there's really no fixed thing, but contents and keep things in good order over lifetime is basically the definition here. So what data is there to manage then? Well, suppose you have some sort of project and this cloud would represent all data that is a part of the project's data. It may exist in a different sorts of sets of tools here. And if you would work with one single tool and you would say, well, we have these routines now to manage data inside an internal tool, you may need to define other ways to manage data in other tools. However, if you use CS Engineering Studio and connect all sorts of tools and containers of data to the same database, you would actually be able to extend the definition of how you manage data to cover all the data that you work with, regardless of what sort of tool it's in. Okay, so managing data is sort of to make it available and make it consistent over time. And that's nothing strange with this. It's only common sense and hard work. Unfortunately, common sense is not always common. So you would need to be very structured to do this. And you need to be able to communicate what you're doing between different people with different background and over time. And this is one of the challenges. There may often be a lot of people involved in different organizations with different roles and so on. And some projects may be ongoing for several years. So you can't rely on individual keeping track of things in their heads. You need to be able to have it all structured and be able to communicate what you're doing. Okay, over time suggests that we have some sort of life cycles. So now what's the life cycle? Well, the definition of life cycle could be something like this. It's a framework that helps us managing a system during its lifetime. And it has phases, for example, study phase, concept phase, development phase, and so on. It typically have milestones, which are typically decision gates where you could proceed or not proceed into the following phase. There may be milestones inside some of the phases. And there are processes to tell you what to do in each phase here. That's a typical definition of a life cycle. So if we will look at this and say, okay, let's call this our product life cycle. This is the life cycle of the product that we are about to develop and to operate. Well, sometimes a project is defined. For example, you may define a development project. saying that we would have a specific project with the task to do the development and to initialize production, or whatever you may want to define this as a project. And the project as such has its own life cycle. You should plan your product, you should execute it, and you should have some sort of project acceptance. This is a very simplified life cycle, but just to illustrate that the project has a different life cycle than the product. And even so, in this phase, in operational maintenance, you may need to define a service for the product to be maintained during operation. And the service as such does have its own life cycle. Also, this means that there will be requirements to define the product. There will be requirements for how to carry out the project, and there will be requirements to define how should the service be provided. So we have different sorts of requirements with different life cycles targeting different different parts of the organization and so on. Requirement lifecycle identifies all data that is to be produced related to a set of requirements during the associated product, project, or service lifecycle. And there must be, of course, rules for how to use the data, how to own it, and how to freeze it, and so on. Okay, if I start from the other end, from a very low level, an individual requirement statement also undergoes a number of steps in its life cycle. So first of all, you may specify the requirement, decide this is the way the requirement should be specified. It shall be blue, or whatever requirement you need. Somebody needs to review this, approve this, and say, yes, this is a good requirement, and it's an approved requirement now. You need to suggest how the verification of the requirement, or actually how verification of the system or product built based on the requirement shall be verified. This is a suggestion, and this is the approval of it. So now you have an approved plan for how to verify the requirement. Verification should be carried out and reviewed and approved and so on. After this, you will have a requirement defined, and you have assured that the system satisfies it. There may be change requests all the way back and so on, but this is basically the life cycle of an individual requirement with its verification data. Well, more often than not, you don't have a single requirement. You don't even have a single specification, because you have a set of requirement documents in different sorts of levels corresponding to the V model I showed initially. You may have business requirements, stakeholder requirements, system requirements, and so on. So for each and every requirement, the life cycle I showed in the previous slide applies, but you need to make sure that it all goes together with the iteration and the recursiveness that I was talking about earlier. So you would need to identify a number of steps where different things will happen, such as defining requirements, feedback, review, freezing, and the breakdown, and so on and so forth. A number of activities will be happening throughout the entire life cycle. As you can see, there are connections between the levels. You would work along these lines, and as soon as you come to a point that you have, for example, planned verification, reviewed it and approved this is a good plan, you should freeze whatever data that is related to these steps to say, now we should change it again only after a change decision. It goes on like this, and with this you could identify a number of steps, and you can identify what data is to be produced by whom, and how should it be reviewed, and how should it be frozen step by step. So this is again a way to structure whatever data there is to be produced, there is to be reviewed, and to be maintained during the rest of the life cycle. So if you freeze things, what does that mean? Well, initially, when you start working with something, you just produce data. Of course, there are rules that you should apply to. following quality requirements for writing requirement statements, writing requirements on the appropriate level for the specification you're working on, and so on and so forth. At some point of time, there should be some sort of halt and there should be review. Hands off the keyboard, people should not work, we should have a review. If it's assessed to be okay, it's frozen, and now further changes may only happen after change request and approval. We could of course say that no, it's not ready, we should do some corrections and have a new review. So this is an interaction between configuration management and requirement management. Configuration management, their task is to decide when some sort of data should be frozen according to reviews and so on. And also further on, when there is a change request, there should be an approval for a change request before the changes are implemented. And requirement management will enable things. We will enable reviews. We will keep track of what data there is to change, which is frozen, which is not. We should be flexible enough to have some sort of incremental way, so we don't need to do this in one single large step. We could also support with impact analysis before changes. Now, if we would change this requirement, we should also redo this verification, and it will have these effects on business requirements and so on and so forth. After change approval, changes should also be implemented in the database. Now we've been talking about requirement, but we should also understand that requirements is not the only type of data existing in the world. There are all sorts of other data that is related to. And the management of the data should really extend way beyond simply requirements. Problem is requirement management is a more or less established expression. I would sometimes prefer to call it information management or something else, because we're talking about more than just only requirements here. Okay, before, after, freeze. As I said, before you freeze, just work on individual people will do their job and they will produce data following rules. And after hands off, don't do anything, but you can issue a change request, and after approval, it could be updated. Why should we freeze things then? Well, internal decisions and milestones may rely on that data is in a known state. There may be external reasons for this. If you, for whatever the reason, send the data to an external party or receive data from an external party, it should be well known what state of the data was during the transition. So there may be other reasons for freezing all the parts of data. And what should be frozen then? Well, of course, requirements, at least identified subsets of requirements. Perhaps not all requirements at one point of time, but also contextual information, giving the background to requirement, definitions defining expressions that requirements are based on should definitely be frozen, and so on. We could also choose to freeze all sorts of attributes and links. I'll get back to this later on, but associated data with the requirement. Okay, but what should not be frozen then? Well, basically the same thing. Other identified subsets of requirements, perhaps requirements for a later version of the same system, or requirements that are in a has to do with a subsystem that is to be produced later on, or so on. So we don't need to do it all at the same time. And there may be some data that never needs to be frozen, some sort of more or less informal notes, remarks, and so on. Ownership of data. If you would freeze it, you would need to have a decision to change it, and so on. That may be a bit impractical. Okay, so we would need not only following the life cycle, but we should also know how to structure the data that we are working with. A structure is something that could be seen in at least two dimensions here. We could have different levels, and we could have different types of requirements. First, let's look at the levels. In 15288, it's identified that we would need, for example, business requirement specifications, stakeholder requirement specifications, system requirement specifications that have their own purposes with their own scopes and so on. And they are leveled in a way that the lower level requirements should satisfy higher level requirements. This allows for traceability. This allows for a clear interface, which may or may not be contractual if you have external parties involved, but even so, you may have interfaces between internal parts of your own organization. This helps us structure change management of requirements and to make sure that verification takes place on each level. However, sometimes it's a bit problematic to lock into these terms here, because from whose point of view are these stakeholder requirements or system requirements, depending on your own part of it. But you could always say that whoever you are, whatever you're doing, these are your requirements. And you do this because somebody else has give you some inputs. Well, let's call them your customers' requirements. And your work will influence somebody else to do something. Let's call them your supplier's requirement. These may or may not be internal or external parts to your organization. This structure still satisfies these bullets up here, but you don't need to be too strict about calling things. For example, your system requirement or your subsystem requirement may be the system requirement for somebody else, and so on. If you would need to extend it, do this from whoever's points of view involved, and you could do this for forever, basically. And you will still have the same structure, but from your own point of view, you'll always have somebody giving you input, and your work will be continued by somebody else. So you would need layered approaches here, and that's the levels, but also you would need to separate the handling of different types of requirements. And why is this? Well, I was suggesting earlier that we have different life cycles, and for this reason we may again have different requirements for projects, for products, or for services, or whatever other things that may be appropriate to define in your case. These should be separated in different requirement documents for the simple reason that they follow different life cycles, different principles, and need of data for verification. You should verify all requirements, but how to verify a service requirement or a functional system requirement is pretty different, and it calls for different sets of data to handle the information related to verification. Different parties may be involved, so there are different needs. Each party should be focusing on whatever requirements document is most appropriate or valid in their case. So what sort of documents may or may we not have then? Well, we should definitely have product requirements. We will find stakeholder requirement, we will find system requirements, or whatever we wish to call them. We may or may not have a specific integrated logistics support set of requirements, utilities, documentation requirements, or whatever, sometimes included here, sometimes not. In any case, it's a part of the specification for the products. Projects, saying how to carry on the project, is also separate. We often talk about statement of work to define what requirements the project as such should fulfill. And service requirement, contracted logistics support, or whatever we would wish to call this, says how should the system be maintained in the operational phase. Business requirement may span over all this, of course. Example of technical requirements could be something like this. We would have stakeholder requirements, or we would have system requirements. They would all be examples of product requirements for defining how the product should be designed and verified. Project requirement could be something like, well, during the project, there should be a system requirement review carried out, and there should be document deliveries according to the contract delivery requirement list, and so on and so forth. has nothing to do with the product. It's more how to operate the project. And service requirements could specify requirements on how the service provider should react on maintenance needs and so on. So we have levels also indicated in this picture, and we have project requirements, product requirements, and service requirements. If we were to put all of this in one container, we would have a problem. So we need to separate this. Okay, some of the arrows here indicate that we have some sort of traceability. What is traceability? According to 29148 standard, which is the requirements engineering interpretation basically of 15288, it identifies traceability to be requirements traceability is has to do with derivation path upwards or allocation flow down path downwards for requirements. Where do requirements come from and what happens downstream with the requirement? We talk about parent requirement and we talk about child requirement. So this indicates that we should need traceability to see why do we have this requirement, where does it come from, and what happens below ourselves in the level. And this is specifically about requirements and the traceability between higher and lower levels of requirements. But I would wish to extend the definition of traceability a bit. This is basically the previous slide, origin of the requirement, and from the other end, how has it been satisfied downstream. But also history is a sort of a different dimension to it. How has every piece of data been evolving over time? That's some sort of traceability as well. Also references to plans, reports, decisions, and so forth and so on. Verification data, design decisions, and all sorts of related data is also something that you could or should trace to requirements and other data. This could be realized in various ways depending on your tools: links, attributes, history features, version handling, and other. There are a variety of ways to manage this. The objectives for traceability, obviously, change control. This is, by the way, from the guide of writing requirements from INCOSE. Good document. I could recommend you to have a look into that. Change control requirements should be layered and traced in such a way that the impact of change can be analyzed. This should typically be done before you have a decision to implement the change. Design documentation, as I mentioned, you should be able to see what design decisions have been made to decide that requirement should be as it is. And again, verification. So we would need to be able to trace what are verification activities and outcomes of verification has been connected to each requirement. The benefits of this are pretty obvious, because if you have requirement traceability, you can navigate upstream and downstream and say, okay, this business requirement calls for these stakeholder requirements, and we have these system requirements to be implemented in a system. They'd be able to, in the end, support the business needs and so on. And if you document this, you would have something that is more stable over time than just depending on experts. We don't need to trace this because we have these and these experts and they know it all, as long as they're around. But traces in a database really every time beats somebody having it all in their heads. You could assess completeness. If you would say you have a business requirement and you have one or two links from lower levels, then you could assess, well, do these incoming links cover all aspects of my business requirements, or this has been completely managed lower down? And the same thing with verification. We do have one or more verification activities related to requirement. Is this complete? You can also see that the requirement, if it doesn't have any links at all, perhaps it has been forgotten, nothing has happened to it. I'll get back to this a little bit more later on. You could also be a bit more high-tech to enable automation, cross-reference reporting and metrics and so on could be produced from your tool based on whatever traceability you have. And well, this is basically the same metrics, percentage of requirement that has been going through verification in different steps. Things like that are easy to obtain by having traceability. You could typically try to illustrate the traceability, something like this. You would perhaps have a system requirement based on stakeholder requirements. You would have subsystem requirements based on this. You would have design decisions on the way. You will have plans and procedures for verification and the results of the verification and so on. So this is a pretty good way of illustrating traceability. Okay, attributes then. What are attributes? Well, there are definitions for everything, 29.148 again, saying that an attribute is an inherent property or characteristics of an entity that can be distinguished quantitatively or qualitatively by human or automated means. I've read this definition and another definition 1,000 times, and I think it's a bit complicated. So why I do things more complicated than they have to be? Attributes capture important additional information. That's basically what this one is saying. To a requirement or to something else, you may have attributes to other types of data than the requirements as well. Things is that you would need to have additional information. Suppose this is a requirement. It's a wonderful, beautiful requirement. But this alone doesn't help you over the life cycle because you would need to know a number of things. First of all, you would need a classification. Well, this is a requirement. It's not obvious. It could have been a piece of information. It could have been a definition. It could have been anything. But now we say this is a requirement. So this is your first attribute, classification. You may assign ownership or responsibility to this, who has written it and who should be responsible for changes and so on. Applicability, sometimes we have variants or versions of things. Is this applicable to all versions of Temperature Warrior or just some variants, some versions? Is there some sort of priority attached to this, related to this or to the rest of the requirements in the same set? Have risks been identified with it, or whatever measures have been taken to mitigate them or whatever? Have we, what's the status about verification? Have we planned it? Have we performed it? Have we accepted it or whatever? What's the status of it? There may be other things such as if you have a commercial thing, is this what you get all the time, or do you need to exercise an option, whatever, to get this? Frozen preliminary, back to status of this individual requirement statement. Why do we have it in the first place? Well, some sort of rationale, justification, and so could be very useful to store. And if you again involve external or internal parties to continue with this, is there some sort of commitment to compliance? Is there any problems with this? Or changes, has something been suggested, has something been proposed or approved or whatever. So as you can see, it's easy to identify a number of things that could be good to manage along with this requirement statement as such. And in the guide to writing requirements, same document I was referring to earlier, there are sets of suggested requirements for different purposes. And this section here shows about attributes to help maintain the requirements. Here are some examples. Identifier, of course, you would need to have an identifier for each object, name, originator, data, owner, and so on. Lots of things has to do with status, that shows you how far along the process you have proceeded, and all sorts of things. This is a good summary of of attributes to requirements or any other pieces of data. But I think some things could be added to this. As we've been talking about, more often than not, we have different levels. They may be business requirements, stakeholder requirements, and system requirements, or whatever you wish to call them. And so there is a need to check completeness in a breakdown. have we sufficiently covered the intention of the business requirement with our stakeholder requirements and so on? And also for verification, do we have one verification, one activity to, one requirement and one verification activity to verify it, or do we need many-to-many relations here? Then we need to verify that we have a sufficient or complete coverage of the verification. And we may also need another type of attribute. If many parties are involved, we may need extended status and ownerships from different parties and so on. So it could be easy to identify other types of attributes in addition to what's suggested in the guide for writing requirements, for example. Now, let's have a bit closer look on specifically this first one. What do we mean with assess completeness here? Well, if we would be in this case, we would have a set of business requirements. We have provided feedback to them from the owners of the stakeholder requirements who have agreed this is the basic set of business requirements, frozen. All or some of the data here may be still not frozen, but anyway, we would have some sort of data to continue to work on here. And we'll go ahead, we'll write requirements. And now these requirements should be reviewed. We may find that these requirements are just fine, they're good quality, they follow the rules, and they address the correct things on the right levels and so on. So we say, well, they're correct, great. But we have this business requirement up here. And these are all linked, traced up here. So the question now is, from this requirement point of view, do all these requirements satisfy all aspects of it? Do we have a complete representation of the intentions up here, down here? This can be not assessed from individual requirement on this level. We need to step up here and say, is this completely covered up here? And this is where we could say, yes, we have a complete coverage in here. So we could assess completeness from one level up. And now we could freeze the outcome of this review as well. And the same thing could happen, and of course, then we will need some sort of attributes to, not least, to indicate how far we have come in terms of completeness up here. And similar approach, if this would be a requirement and this would be a number of verification activities, we would do the same similar thing to say, do all these verification activities altogether satisfy or prove that all the aspects of this requirement has been checked and verified. Okay, and so we will have a bunch of attributes and we would need to document them. And for each class of information, for example, a statement of work or a system requirement specification or whatever, we would need to define what are our attributes, what's the name of it, what's the name of each attribute, how do we use it, what possible values could it have, is there any specific conditions, and so on and so forth. So we need to identify a number of sort of rules for each requirement. If we let this all free, you could be sure that the creative engineers can figure out thousands of attributes in their own needs, and you would have a random attribute sets and you would confuse everybody. So you need to restrict this. And this is important. How do we use an attribute? If we have a sort of problem to identify or define, why do we need this attribute? Perhaps we don't need it. So be critical here and don't add too many attributes, because this is a common trap. You could say, well, it's good to have, well, let's add an attribute, but there's work associated with adding an attribute because you need to maintain it. This is actually a quotation from Three Men in a Boat by Jerome K. Jerome. I think it's a wonderful statement that definitely applies to requirement management also. We must not think of the things we could do with, but only the things we cannot do without. So don't get carried away. Okay, drawing the map, trying to wrap things up a bit here now. main component of the requirement management map to help you navigate through life cycle and communicate to all parties. We would need to define structure. What sorts of containers of data do we have in what levels, and what types, for example, project and product and service or whatever we may have, should be clear. So everybody should know the scope of each container of data or requirements here. We should have traceability rules. What should be linked to what and for what purposes and how. We should have attribute sets, as we have also been talking about, defined to say exactly the use and need for each requirement. And we should have the requirement lifecycle, saying that this and this and this would be happening at this time. And the data produced here and here refers back to attributes or traces, or something that needs to be created and reviewed and frozen in different points of time throughout the project. So a documentation of this in one way or another is essential, and is something that you should initially do when starting up a project, which you say, okay, we now have these all these things, all this data, this is the way we should maintain it. Document this during project startup, but you will of course need to revisit this during the project or the life cycles that you're following, because you may find different needs popping up, and you may figure out smarter ways to manage data and so on. But if you have a map, it's easier to update something and say, now this is the way we do it now, communicate that, and just change it and hope that people understand what you mean. Okay, so back to this picture again. It's not only about developing data, it's also about managing over time. And tools to support, we support this is a good tool, a very powerful tool. Is based on ontologies, knowledge manager, requirement quality analyzer, and so on. That is very powerful, not least in this area where we decide to, where we actually produce the data. We also can, using SES Engineering Studio, connect all sorts of repositories and add these functionalities in all these tool sets to help us maintain data in similar ways, regardless of where data is stored in the different tools over life cycle. So by this, we have a few short demonstrations. I'm looking at the time now. Since we had a little slow start, I think we would need to speed up a bit, but I will still like to go through the small demonstrations here. First video is about how to define attributes. Now in System Engineering Studio, we have a number of repositories for data for different purposes with their own basically for whatever project we're working in. If I open one of them, we can look at connections to different repositories, Word documents, Excel files, whatever other data. We could add connections to a variety of repositories here, but we have a few now. Let's have a look at this Word document. If we open this from within SES Engineering Studio, we have a list of requirements. We can have content view, quality view, and so on to operate the tools connected to the SES Engineering Studio. And now we could add attributes. So we could manage column, and we could add a column including a new attribute. Say we would want to have an attribute now. What should it be? Well, we perhaps need a comment attribute for whatever reason. And we well, need to associate with a data type string in this case, meaning free text data. And we have it added, and now we have a comment attribute to data that's actually residing in a Word document. It could be to any data in any repository, but here we can write our comments to this specific statement for whatever reason. Save this, and we will save the changes. And again, this is something that is run from SYS Engineering Studio, but it also affects, depending on settings when you do the connection, data in the well, in the repository it comes from or not. But now we at least have this comment here to this requirement statement. We could go on and manage all the columns and so on. We could add more data, the different ways into the same things sometimes. Let's have another attribute. We will need some sort of status attribute to see how far down the road we have been going. And this should typically be an enumeration, and we have predefined an enumeration here which is called status, with a set of values relevant to indicate how the progress has been for each and every statement in here, for example, in review or approved or whatever. And this should, of course, be adapted to how your process has been defined. So we can identify text requirement, we can identify other types of requirements, in this case enumerations with pull down menus, we could rearrange things and so on. And this could be done, in this case we're talking about the connection to Word, but this again could be done to basically anything that we have a connection to. So, and we store this and we have its data has been saved in the database. Okay, so this is a very quick presentation of how attributes can be defined. Now let's see what we can do when we have data in a Word document and want to operate with this. This is a Word file, and within Word we have an add-in which takes us to SES Engineering Studio from within Word. We could show panels, for example, the content view, which is the same panel as we could see in the other video. If we select a work product here, we would have the same selection in the content panel, and we could modify data in Word. And as we do this, the modification also, of course, takes place in the content view here of the SES Engineering Studio. What happened? Yeah, here we go. And now when we have it in here, we could do all sorts of things. We could, for example, check what versions of this statement we have, and we could review changes from one version to another, or we could have a list of previous versions for the same product, and we could say, no, this was not a good idea, let's revert this, and we'll change it back, or do whatever other activities we have. Now it's restored, same thing in the Word document. Another thing now is that we say we have this requirement statement and we wish to assess quality for this. We open from the SES Engineering Studio panel the requirement quality analyzer, and we have instant quality analysis of data in this Word file, and we could change and update the requirement to increase the quality. And doing so, let's save this and close. Now we have assessed quality through SES Engineering Studio, and the data has been updated in our Word file. Now we could change the attribute to approved and give it whatever command, for example. So it's a way to manage data regardless of the repository that we initially have the data in. Okay. Finally, there is a short video about traceability of data in different formats. Again, we're back in SES Engineering Studio. We have this traceability tab here, and we can open this and we could have defined a traceability project. And in this, we have a traceability module saying that we should have the source in the Word document and a target in the Excel file. These are two of the connections we have here. Let's open them up. So we have a source and we have target here, and we have the traces defined. Now we can see what traces we have. We have from this source to this target, we have a trace already. We could navigate from source to trace and back and forth. See, this one is linked to that one. We could, let's see what's next now. We could select a new set of objects and produce new traits between them. And do whatever operations we want to do on the trace and delete and so on. Again, we could say we have one source and we could want to link this to perhaps more than one target, 1 to 2. And we trace this, and we will have 2 new traces defined. This one to 59 and this one to 60 in the target container. So now we have created traces. Now let's have a look on the result of this. So we can use this mapping tool now to visually indicate that we do have from Word, from data in Word file to data in Excel file. We have a number of traces. This is something that could typically be used to verify that we're following the map that I was talking about earlier. Now we do have these traits, we don't have anything else, so we're consistent with the mapping that we have defined. Okay, that's a bit short about the demonstrations, and now we are basically on time, but we got a little slow start, so we have a few minutes still. So Cecilia, should we proceed with the next, some information about the next, or do we have any questions, or what's happening?
Yes, thank you for the presentation, Lars. Yes, we will. If you want to ask any questions, you can write them down in the questions section, and I will just quickly tell you about our upcoming webinar. This webinar is organized by Oveo, and it's called Connecting Textual Requirements and Capella Models. CES Engineering Studio, achieving the perfect equilibrium between textual requirements and models in Capella by automatic interoperability, quality, and traceability operations. During this webinar, we will show you some capabilities of CES Engineering Studio with Capella models. And the date is the 23rd of June, and you can find more information and register following the link. We will send you a link to both the recording of this webinar and to the presentation of this webinar, so you can find this link there. So let's see if we have any questions. Yes. What other project data is there in the cloud?
Okay, yes. This, I think, may refer to this picture. I was saying that we have a number of data that we manage, but there may be other data. So what's outside the cloud? Well, basically, it could be anything that is related to the project. It could be all sorts of plans. It could be reports. It could be definitions of things. It could be contextual information and anything. And the thing is, you may or may not include this in the set of your managed data by expanding the definition of this managed data. There could always be something out there that somebody could send an important email that has something to do with the product. You will probably never catch it all, but you should be assured that whatever you happen to have in your database may not always be the entire set of data existing in the project. So a good thing would be to expand this yellow box to cover as much of the cloud as possible, but be sure that there is always something outside there that you don't have full control of. Okay, I hope that answers the questions, or this question at least.
Yeah, thank you. Do all requirements need to be verified? For example, statement of work requirements.
Yes, yes. You should always verify whatever requirements you write. If you don't, if you have a requirement in here or in here and here, and you don't verify it, why do you write it? You need to verify it. But the way to verify a requirement is different from depending on what type of requirement it is. Suppose you have a technical requirement specifying functionality. Then you may need data to set up and define and perform verification with the measurement tools and all sorts of things. You may also have a service requirement saying that the service should be provided with this and this service level as agreed. And then you may need to collect statistics and analyze that to say have the requirement been fulfilled or not. But if you have a requirement, of course you need to verify it. That also is the case for each and every level, but you may decide if you are focusing on this one, you may or may not worry about how these requirements are verified. That may be the job of somebody else in another part of your organization or some other organization. But yes, you need to verify it all. If you don't intend to verify it, you should consider not to write the requirement in the first place.
Okay, thank you. When do you need more than one verification action per requirement? Could you give an example?
Okay, yes. Okay, suppose we have, well, it could be argued that if you need to verify more than one thing, perhaps you have a bad requirement containing more than one requirement in one statement. But you could, for example, say you have a requirement saying that the system should operate in this climatic zone defined by some sort of standard. Then there's typically a higher temperature level and the lower temperature level within the same requirement. So you may need to verify that it actually does work in minus 25 degrees, and you need to verify that it does work in plus 50 degrees. This is the two verification activities that you need to perform based on the same requirement. It could also be so that if you have a complex requirement, you may want to verify on some sort of a component level in initial design, and you may want to verify in operation out there in the field later on to be sure that the requirement is fulfilled. So you may need to do more than one thing. And by doing more than one thing to verify a single requirement, you should also then assess that it has been completely verified as intended. Okay.
Thank you, Lars. We have no further questions. So thank you very much, everybody, for attending. If you have further questions later or want more information, don't hesitate to contact us by email to contact@reusecompany.com or through our website, reusecompany.com. Thank you very much and goodbye.
Thank you. Goodbye.